So now we're going to use those physical and chemical changes to help us separate mixtures. So remember, a mixture could be a homogeneous mixture, which is also called a solution, or it could be a heterogeneous mixture. So let's first look at physical separations. So in physical separations, the most common one is filtration. So in filtration, you separate out particles based on particle size. So if I did some sort of chemical reaction where precipitate was formed, I could take some filter paper and I could pour that solution with the precipitate through the filter paper, and then that would leave the solid back on the filter paper that I could take and dry. The same sort of principle is used when you make your mac and cheese. So you put in the noodles into the hot water, you let it cook, let the noodles absorb that water, and then how do you separate the noodles from the water is you use a strainer. And that's the same type of physical process of using particle size. Distillation is a way of separating mixtures based on boiling point. So if I had a solution that had two liquids in it, how could I get both those liquids separated from each other? So what you would do is put those two liquids right here, and you would heat them up, and you would closely monitor the thermometer. And this would only work if there was a difference in boiling point between the two liquids. So as it boils, that that gas that comes off would be forced through the condenser, and the condenser would turn that hot gas or that hot vapor back into its liquid state, and then you could collect that off. So this is exactly how they do alcohol. They take the fermenting mash and they put it over low heat, and they keep the temperature very, very low, like around 70 degrees Celsius. We know that water boils at 100 degrees Celsius. So to they to distillation is a way of separating mixtures based on boiling point, and it's a way to separate out a mixture of two liquids. They would both need to have different boiling points. So you would put both the liquid mixture over low heat, and then you would watch your temperature closely, and you would keep the temperature at the lower boiling point of the liquid that has the lowest boiling point. And then as that liquid becomes a vapor, you would put it through a condenser. In the condenser, it's a jacket of cold water that will cool that vapor, and then it will turn it back into a liquid that you could then collect. A good example of this is the backyard still that you read about in Huck Finn. And his father was always off tending his still. So how that whole process works is you take the fermented mash, so whatever it is that you're fermenting, some grains or whatnot, and as it ferments, alcohol is formed, but then you need to separate that alcohol from all the stuff that you don't want. And so you keep the temperature really low at the boiling point of the alcohol, which is between 70 and 80 degrees Celsius. And so as that alcohol vapor comes up, again, it goes to the condenser, that jacket of cold water, and then it cools and it is able to drip out and to collect. Distillers have to be very, very careful because there are some alcohols that are formed that can actually cause blindness if you drink them. And so you have to really know what you're doing in order to do this distillation. And you have to really monitor your temperature to make sure you get the stuff that won't uh, make you go blind. A distillation column, this is another type of way to use physical properties to separate out a mixture. And this is called fractional distillation. So this is exactly how we get gasoline for our cars and our vehicles. So the crude oil comes in and it is heated up, and there are different temperatures in this column here. And as it heats up and the vapors go up, as they cool, then it is able to be collected. So You see we have bottle gas up here, so that's the coolest that's collected. And here's the fuel for our cars just there. The stuff that's down here at the bottom, they do use everything from the crude oil, so they'll take the stuff left over and they'll use it for our roads and our roofs. As you drive down Highway I-15, you'll see these big things. This is a distillation column. So just to go back, again, they monitor the temperature and they're able to collect different vapors based on the temperature at which it will condense back into a liquid. All right, some other ways to use physical processes to separate it. We have magnetism. So this is a junkyard where they're able to collect the metal that they can use to recycle. And they have this magnet that they're able to turn it on and turn it off. So they're able to move the metal around, that they can melt it down and that they can reuse. Fractional crystallization is based on a different ability to dissolve. A good example of this is if you pour a bowl of Cheerios and you put 1 scoop of sugar in your Cheerios with the milk, maybe 2. And when you're done eating your cereal, what's at the bottom of that bowl of milk? And it's this sugar sludge. And the reason that it's there is because of the temperature. Not a lot of sugar can dissolve into that milk. So if you were to warm the milk up, you would be able to dissolve more sugar. So by keeping the temperature low, then we prevent that sugar from dissolving all the way. The number 5 here, chromatography. Chromatography is a way looking at how molecules are attracted to other molecules. And so it's called chromatography. So for example, there's some sort of packing material right here in this burette, and you put the sample up here at the top, and then you pour some sort of liquid down here, and the liquid is going to cause the mixture to separate. So as you can see that this is long enough so it gives it time that each of the different components of the mixture will separate out. And you just keep pouring and keep pouring the liquid down through. And what was represented in red, it might be attracted to the liquid that you're pouring down. And then as it gets down here to the bottom, you just get a beaker and you're able to collect it right here at the bottom. Okay. Let's look at the next one. The last one that I thought of using physical properties is using a centrifuge. So, and this is what they do when you give a blood sample and they need to get rid of the cellular component of your blood. They just want to look at the liquid. So they'll take that sample of blood and they'll put it in a little tube. They collect it and then they'll put it in a centrifuge and they'll spin it down. So the cells, like the red blood cells and the cellular parts of the blood, they're heavier than the liquid, so they will sink to the bottom. And so this just spins around and around really, really fast. And so the heavier parts will go to the bottom of the test tube, and then they can just pour off the top part. Chemical separation. So this is using chemical properties to separate out mixtures. And a good example of this occurs in Rio Tinto mine that's just west of Riverton High School. Rio Tinto, it's a copper mine, but it also pumps out a lot of gold too. And so what they do is they gather this ore. So you have these chunks of rock here, and they need to somehow get the gold out of the rock. So they actually take and they crush it into smaller pieces, and they put in these big vats, and they add cyanide, and the cyanide reacts with the gold and makes the gold dissolve, which I think is just incredible. And then they're able to just skim it off the top. If you really think about it, gold's pretty heavy, and if you just pour a whole bunch of water on the gold rock, all of that gold is going to be at the bottom of your vat. But by adding this cyanide chemical, they're able to dissolve the gold and the gold floats to the top, and they're able to pour off that cyanide gold mixture. And then they just reverse the chemical process by adding some more chemicals, and they're able to get the gold out. And I've included a YouTube video that discusses this if you're interested.